hope you guys are having a wonderful Saturday. We are going to get into our math lesson here. I was doing a little reflecting on our math time yesterday. I know that lesson 11 was confusing for a lot of us for a variety of reasons. Maybe you did not watch the video as well as you should have on Thursday night. Maybe your teacher shouldn't have assigned homework on the night of big fundraiser at school. So we are going to revisit lesson 11. We are going to kind of hit pause on lesson 11 and we're going to take a look at it again on Monday. So right now what we're going to do, we're going to review lesson 11 and we're going to look at the place value modeling of multiplying by decimals, and then we're also going to look at that area model. So by the time this video is over, you should feel pretty comfortable with modeling the multiplication of decimals on the place value chart and on the area model. If you're not comfortable with it, you need to rewatch this video or rewatch the original lesson 11 video, because when you come into school on Monday, you are responsible for having that information in your head, and you need to come to school on Monday ready to practice. As we all know, some of us were not ready to practice that yesterday, and it was not our most successful math class ever. But that happens, and we are going to regroup. I know that you're all capable of modeling this really well, so we're just going to kind of hit the pause button, like I said, work on it a bit more, and then we will move forward. Okay, so let's take a look at some problems. Okay, hooligans, we are getting into, I'll just call this L11.5. Lesson 11.5. We're going to do a lesson, we're going to dedicate one more day to lesson 11.5. So let's look at some modeling. I set up a problem here that reads 3 times 4/100ths, or 3 copies of 4/100ths. When we're modeling, again, we need a nice wide place value chart. You're going to set up the place value chart with columns that are much wider or fatter than we typically use, because we're going to need to model. This particular place value chart, I'm putting the decimal right here, and please remember your proper place values. The place value immediately to the left of the decimal are ones, then we have tenths, continuing to the right we have hundredths, and then down here we have thousandths. Okay, so here's another check-in. How are you feeling about place values? Do you have these memorized and committed in your heart? Can you fill out a place value chart in a pinch? Are you comfortable with the order of each place value? If any of the answers to those questions is no, this is going to be an opportunity for you to review. This would be a wonderful opportunity right now for you to hit pause in a moment and draw a place value chart in your math notebook and review your place values. If you do not have these committed to memory yet, we are going to be very confused as we move forward. The understanding is that at this point, you have your place values memorized. Now we're going to take this learning, our place value learning, and now we're going to apply it to more complicated situations. This complicated situation, for instance. When we're modeling, if you're wondering which number are we starting with and then how many copies are we making, ask yourself this. Would you know how to model 4/100th copies of 3? I wouldn't. I have no idea how to model 4/100th copies of 3, but I do know how to model 3 copies of 4/100ths. So just use your logic. Logic is our friend. Logic keeps us out of trouble. Some of you were doing some very illogical things yesterday. So use your logic before you leap. So we're going to make 3 copies of 4/100ths. Here I have 4/100ths. I need a total of 3 copies of 4/100ths. And then we're going to think about, what does that number look like? Okay, so now I have 3 copies of 400ths, and we're going to count out these hundredths, and we're going to find 4, 8, 12 hundredths. You guys know that we cannot have 2 digits and 1 place value. So what are we going to do? Well, we are going to lasso, or we're going to bundle up 10 hundredths. Whenever we're bundling or unbundling, we're always working with this magic number 10, because the place value chart relies upon the powers of 10. As we move to the left or the right, as we move to the left, our numbers become 10 times as large. As we move to the right, our numbers become 1/10 as large. This place value chart all relies upon powers of 10. So when we're bundling or unbundling, the magic number is 10. So we're going to take 10 hundredths and we're going to move them next door, because we cannot fit 12 hundredths in one column, because 12 is 2 digits. We can only have 1 digit per column. So we're going to bundle up 10 hundredths and we're going to transfer them into 1/10. They are no longer hundredths, they are now just 1/10. So now we don't have 12 hundredths in our column anymore. Now we have 2 hundredths. And we have 1/10. Don't forget our decimal place. So when we're making 3 copies of 4 hundredths, our final product will be 0.12, 12 hundredths. But just keep in mind what happened in our place value chart. Our 1 is in our tenths place value, and our 2 is in our hundredths place value. We do not have a 12 smashed into our hundredths place value, because that just does not work. Okay, now let's take a look at some area models. Buddies, let's take a look at this area model. Area models start with a rectangle. So I have a rectangle here. I went ahead and cut this rectangle into 2 parts. And I want you to think about why I would cut the rectangle into 2 parts. I'm just going to set up our expression up here. Let's take a tour of the area model. Right here, we are going to write the number of copies that we are seeking to find from our expression. Here, this section, and here, we are going to label, I'll draw a blue line, we are going to label each of those rectangles with a piece of the number that we are going to break apart. Okay, within each of these rectangles, we are going to have within each of these rectangles, we will have 1 multiplication expression. Inside the rectangle, we have the multiplication expression. You're going to multiply, and then you're going to put the answer below the rectangle. So we're going to end up with 1, 2 partial products. Partial products are not the final product. In order to figure out the final product, you're going to have to add our partial products together, and then we will find our partial product. Okay, so let's take a look. We're going to look at 4 copies of 2 let's say 2.3. Oh dear, calc got hurt. Okay, so our expression is 4 times 2.3. We're making 4 copies, so we're going to label our area model, and we're going to put our 4 right here, and then we're going to break apart 2.3 into each individual place value. So our 2 is going to go here, and our 0.3 is going to go here. This number has 1, 2 place values, so our rectangle has 1, 2 pieces. We're making 4 copies, so we have our 4 labeled right here. Okay, so now we need to go ahead and write our expressions inside each of our rectangular pieces. So here we're going to make 4 copies of, here's the 4, 2. Because there's a 2 on top of this section of the rectangle. For this rectangle, we're still looking at 4 copies of, but this section of the rectangle is labeled with a 3/10. So our expression for this side of the rectangle is 4 times 3/10. Okay, so we have that labeled. Now we need to do our multiplication. What is 4 times 2? Well, 4 times 2 is 8. Great. Now we have to think of what is 4 times 3/10. Well, I know 4 times 3 is 12. Don't forget your decimal point. 4 times 3/10 is going to be 12/10. This is 12/10. Now I have 2 partial products. We need to add those together to find our final product. Let's go ahead and add those together in some space that we have. Although 8 doesn't have a decimal point, we can add 1. We know that there are 0/10 and 8 ones. So we are going to go ahead and fill that in because we're adding 8 to 1.2. And when we're setting up our addition of decimals, it's so important. It's imperative, which means very, very important to keep our decimals lined up, our ones place value lined up, our tenths, and then if you add any more, you need to make sure those are lined up as well. We put our 0/10 in here just so we can make sure that this stays lined up. Now we can just very quickly add. 0 plus 2 is 2. Go ahead and bring our decimal place down. 8 plus 1 is 9. Great, so our final product here, you guys, is going to be 9.2. Next, let's look at 5 copies of 2.4. Okay, so all of my labeling is still here. Let's go ahead and start filling in our area model. I'm looking for 5 copies, so I'm going to label this end of the rectangle with 5. This end of the rectangle is labeled with our number of copies. Now we are making 5 copies of 2.4. I'm going to break apart 2.4 into its individual place values, which is 2 ones heading off this rectangle. This is the 2 1 section of the rectangle. This side is going to be labeled with 4/10. So we just cut that number into its 2 parts because there are 2 place values shown in the number. So we have our 5 copies of 2.4. Now on the inside of the rectangle, we're going to write out our multiplication expressions. Here we have 5 copies of 2. So that looks like 5 times 2. In this rectangle, we're looking at 5 copies of 0.4 or 4/10. So our expression will read 5 times 4/10. Okay, so we have this labeled. Now let's look at our 2 partial products. We're going to have 2 partial products because we have 2 sections of the rectangle. We have 2 sections of the rectangle because the number that we're making copies of has 2 place values shown, ones and tenths. Okay, so now let's do our multiplication. 5 times 2 is 10. 5 times 4, see how I'm doing this, is 20. But this isn't 4 ones, these are 4/10. 5 times 4, 5 copies of 4/10 is 20/10. So now we have 2 partial products. We need to add these partial products together in order to find our final product. Let's go ahead and do that over here on the side. So I have 10 ones. I'm going to label that I have 0/10. I guess I don't necessarily have to do that, but I did. We're adding 10 with 2, which I hope most of us can do this in our head. Doing this a very long ways, but that's fine. 0 plus 0 is 0. We bring down our decimal. 0 plus 2 is 2. And then we have 1 plus nothing is 1. So our answer here, my friends, is going to be 12. 5 copies of 2.4 is 12. Beautiful. We are going to take a look at one more problem here. But as you guys can see, I've taken away all of the labels. We are going to look at, we are going to look at 3 copies of 2.45, or 3 times 2 and 45/100ths. Okay, we are looking for 3 copies of, so let's go ahead and start labeling our area model. We know that right here is the esteemed place in which we write the number of copies that we're looking for in our expression. We know across this top line is where we're going to label each part of the number. This number has 1, 2, 3 place values shown. So we need to go and cut this rectangle into 3 pieces. We are going to decompose or tear apart this number into each particular place value. So we're going to label this first part of the rectangle with 2 1s. The second part of the rectangle, and don't forget your decimals, is going to be labeled with 4/10ths. And this third part of the rectangle is going to be labeled with our 5/100ths. So we've decomposed 2.45 into each of its place values: 2 1s, 4/10ths, 5/100ths. Okay, so now we have this labeled. Next, we need to write the 3 expressions that we will find in each piece of this rectangle. First, inside this first chunk, we have 3 copies of 2. That expression looks like this: 3 times 2. Here we have 3 copies of 4/10ths. That expression looks like this: 3 times 4/10ths. Finally, we have 3 copies of 5/100ths. So our expression will be 3 times 5/100ths. So notice now, you guys, we have 1, 2, 3 parts of the rectangle because the number that we're making 3 copies of has 1, 2, 3 place values shown. So instead of 2 partial products like we've had for the other examples, we're now going to have 1, 2, 3 partial products. We will have 3 partial products to add together in order to find our final product. Okay, so now let's go ahead and evaluate these expressions. First, we have 3 times 2. 3 times 2 is 6. 3 times 2 is 6. That actually makes me think of our secret word for the weekend, which is going to be fried chicken sandwich. I wish I had 6 fried chicken sandwiches. We just had Chick-fil-A for lunch in the Calamara's household, and I had the fried chicken sandwich for the first time in my life. And I don't know if I've ever had anything more delicious than a fried chicken sandwich. Oh my gosh. I feel like I haven't been living my best life until today. Secret word, fried chicken sandwich. For those of you that have not had the fried chicken sandwich at Chick-fil-A, I would beg your parents to take you there as soon as possible because it is delicious. And for those of you that have had the fried chicken sandwich at Chick-fil-A, why didn't you tell me about it? Because, gosh, I'm just missing out on all the years I've lived without having that fried chicken sandwich. Anyway, let's get back to math. Okay, now we have 3 times 4/10ths. Well, I know 3 times 4 is 12, but 3 times 4/10ths is 12/10ths. Don't forget the decimal, very important. 12/10ths and 12 are not the same number. This represents 12/10ths, this represents 12 ones. They are not the same number. Don't forget your decimal. Here we have 3 times 5/100ths. Well, I know 3 times 5 is 15, but this is 3 times 5/100ths, so don't forget your decimal. 15/100ths. Beautiful. So now we have 3 partial products. Let's add our 3 partial products together up here in order to find our final product. I'm, again, adding my decimal to my 6 ones, and I'm including the fact that we have 0/10ths and 0/100ths. So we have 6 plus 1.2. 1.2 has 0/100ths. I'm making sure that each of the values that I'm adding together has the same amount of digits present, just because it is really much easier to add them up when our place values are all filled in with the same amount of digits. Even if it is a 0, it's still a digit. Okay, so now we see 6 has 3 place values, 1.2 has 3 place values, and 0.15 has 3 place values. And again, we have our, I'm just adding these up over here in the corner because it's easier to add vertically as opposed to adding horizontally. We just want to be very precise with this. Okay, so now we can just quickly do this. 0 plus 0 plus 0 is 5. 0 plus 2 plus 1 is 3. Thank you, Sebastian. I know he's thinking the same thing I am. 6 plus 1 plus 0 is 7. Thank you for that, Olivia. Our final product here, you guys, 7.35. Make sure one of these area models is in your math notebook. Make sure you completed one of these problems with me. Make sure that you have a wonderful weekend, and make sure that you come into school on Monday ready to practice this in small group with yours truly. Until we meet again, I'll see you guys Monday.